let's take a look at another function. Let's call it fill-up. Now, I've already filled out this input-output table with some of the inputs and outputs for this function. Now, I hope that you haven't tried finding a formula for this function because, to be honest, there isn't one. I just picked random numbers. And this is a really important note that a function doesn't need to have a specific formula or equation for each of its input-output pairs. For instance, the rule for this function is that 5 is mapped to -3, and 2 is mapped to 17, and -1.4 is mapped to 5.6, etc., etc. Now, why don't you take a second to try to draw a mapping diagram for this function on your own? So why don't you pause the video now, try to draw a mapping diagram, and when you're done, play it, and we'll reconvene. All right, so here's our mapping diagram. Now, quick question. I noticed that a whole bunch of our inputs are all mapped to the output -3. So, is this indeed a function? Well, let's take a look at the definition again. Remember, a function is a relationship in which each input has exactly one output. Is that the case here? Yes, this relationship is a function. A function may have a single output that has multiple inputs. For instance, -3 has 3 different inputs that go to it, but that's fine. It wouldn't be okay for a single input to have multiple outputs. Okay, let's have you try to do the ordered pairs representation on your own. Once again, why don't you pause the video, try drawing out the ordered pairs for Philip, and then playing it, and we'll reconvene. All right, so here's our ordered pair representation. Couple of notes, always a really good idea to label your representation with the name of our function. Right now our functions have really nice names like Philip and George. Later on they're not going to have such nice names, but always a good idea to label them. And whenever you're doing an input-output table or a mapping diagram, definitely want to label the inputs and the outputs as well. Okay, let's look at another one. All right, so like I said before, while most of the time our inputs and outputs are going to be numbers, they do not have to be. So here's an example where neither our inputs nor our outputs are numbers. And let's name this rule something. We can name it whatever we want. Let's name it something random. Let's name it duck. So the name of this rule is duck. Now, perhaps you've already figured out the rule for duck. And in this case, the rule is the output is going to be the first vowel of the input. All right, once again, let's have you try to make the mapping diagram on your own. Why don't you pause the video, draw the mapping diagram, then play it, and we'll reconvene. All right, so there's our mapping diagram. Again, this is a function. Even though 3 different inputs all go to the output A, it's never the case that a single input has multiple outputs. A word can only have one vowel that comes first. It's impossible to have 2 vowels that both come first. So there's no way that one input is going to have multiple outputs. Once again, let's have you try to make the ordered pairs. Why don't you pause the video, make the ordered pairs, and then unpause the video, and we'll reconvene. All right, so there are our ordered pairs. For our next example, we're actually going to take the relationship duck and we're just going to reverse the inputs and the outputs. So our new rule in this case is going to be the output is any word whose first vowel is the input. So what does that mean? If we look at our table of values and mapping diagram and ordered pairs, all we're going to do is just reverse what our inputs are and what our outputs are. So I'm going to go ahead and do that with the table of values, the mapping diagram, and the ordered pairs. I urge you to pause the video. It'll take a little while, but please reverse the inputs and outputs to all 3 of those representations, and then we're going to discuss whether this new rule is actually a function. Okay, so here are the 3 representations for this new rule. So the big question, is this rule a function? Is it the case that every input has exactly one output? The answer to that question is no, and maybe it's the most obvious to see in our mapping diagram. It's clear here that the single input A has three outputs: baseball, cactus, airplane. In fact, if we think of all the words that have A as its first vowel, there are going to be tons and tons of outputs for that single input. So this rule is not a function. You can see it as well in our table of values that A is an input 3 times with 3 different outputs. And in our ordered pairs, there are 3 ordered pairs whose first entry are A, meaning that the input A has 3 different outputs. So in this case, not a function. Alright guys, that's it for this video. I hope you found it helpful and I hope you enjoyed.